Number 20, two projectiles A and B are launched from the ground with velocities of 50 meters per second at 60 degrees, that's projectile A, and the same 50 meters per second at 30 degrees, projectile B, with respect to the horizontal. Assuming there's no air resistance involved, which projectile has the greater kinetic energy? That's what we're looking for, kinetic energy. All right, so we have one projectile that's going up at 30 degrees and another one going up at 60 degrees with respect to the horizontal. So what we do know is that eventually when they reach the top of their apex, when it's at its highest point, it's going to have no velocity in the y direction, but the velocity in the x direction is going to be constant, right? It's going to be equal to, oh, that was wrong. So the velocity in the x direction is going to be equal to the initial velocity in the x direction. All right, so what we need to do is find out the velocity in the x direction. So we're going to need this velocity. So if we look at that, we have a right triangle, so we're looking for the adjacent side. So cosine of 30 degrees times 50 meters per second, or cosine of 60 degrees at 50 meters per second. So the cosine of 30 at 50 meters per second comes out to be 43.3 meters per second, and the cosine of 60 times 50 is going to be 25 meters per second. So it looks like the projectile that's coming off at 30 degrees, which is projectile B, would have a greater kinetic energy because its velocity in the x direction is going to be greater at the apex.